All right, so for 6.3, addition and subtraction of rational expressions, when you add or subtract fractions, we need a common denominator. So the steps to doing this is that you can, one method is that you can factor the denominator. So that you can see what is needed to get a common denominator. And you only need to worry about the denominator. In fact, only do the denominator, because if you do the numerator, you won't have like terms to combine. So step 2, determine the missing factors or factor from each fraction. And then we'll multiply by a giant 1 made from the missing factors. Again, we want the numerator in standard form so we can combine like terms. And we want the denominator in factored form, so we can see they're the same, and so that we can potentially cancel out common factors in our simplification once we've added the expressions, because again, we're adding or subtracting these rational expressions. So combine and simplify if possible. So the denominator here is a difference of squares. So it's x plus 3 times x minus 3. So to get a common denominator, I would need to have not only this x minus 3, but also an x plus 3 factor. But I don't want to change the value of the expression over here, so I have to do x plus 3 over x plus 3. So I'm really just multiplying by 1. So I'm not changing the value of this, but I'm writing it so that now I have a common denominator. So this is now x plus 3 over x plus 3, x minus 3, plus, and I'll go ahead and FOIL these, because it's this quantity times this one, x squared plus 3x plus 3x plus 9 over x minus 3, x plus 3. So again, I'm not distributing, multiplying out the denominators, because I want to see that they're the same. And when I go to simplify, it's good if they're factored so that I don't have to then factor it all over again. So now I'm going to combine. I'm going to add these expressions because they have a common denominator. There's that common denominator. So when I add these together, I have x squared, I have 3x, 3x, and an x, so I have 7 x's. I have 3 and 9, so that's 12. So now at this point we've added them, but what about simplifying that expression? So we learned about simplifying back in 6.1. Factor So this is x plus 4 times x plus 3. Again, the a is 1, so I can just use those. I don't need to do grouping. You can if you want, but it'd be a wasted step. Cancel out the common factors, just like we did in 6.1, so your answer is x plus 4 over x minus 3. It is just a quick review, there are restrictions like x cannot be 3. It could also not have been -3 because the original expression would have been undefined at 3 and -3 and 3. So here's a couple other examples. So I factored this. X plus 3 was missing. I FOILed. I combined these now that I have a common denominator. And then I factored it. And when I tried to factor the numerator here, there was nothing that worked. Again, a times c is 24, 13, nothing works. So I was stuck like this, so that's my answer. On this one, I needed to have an x plus 3 factor from this side, and I needed to have an x plus 1 factor from this fraction, and distributing and distributing, combining like terms, factoring it, it's already as factored as it can be, canceling out common factors. This goes into this one time, so that's why it's 1 over. These still have to be in the denominator, so it's 1 over. A hint or a trick for subtracting is to change it to adding the opposite. If it's just one little thing here, you can do it to adding the opposite when there's 2. You just have to be careful and make sure that you would change both this and this term. All right, so factor the bottom here and the denominator, and I realized I'm missing an x plus 4. Distribute, combine like terms, factor if possible. Nothing canceled, so that was as far as I could go. Here's another difference of squares. We have an x minus 9 missing, so we do x minus 9 over x minus 9. FOIL. Then don't forget you're going to subtract both of those things. So you're going to do x squared minus x squared, no x squareds. Here you have negative 10x minus a negative 11x. That's the same thing as saying negative 10x plus 11x. That's 1x. And then you have 9. And then there was a common factor. Again, went in one time, so it's 1 over x minus 9. Here's an example where it might be helpful to put it over 1 so that you can see that 3x plus 1 is the common, would be the common denominator. And this doesn't factor any further, so that's as far as you'd go. Another one with slightly different factors, like the factors here are 4 and x are not quantities, and what was missing is this quantity x minus 5. Distributing, or in this case just multiplying 4x times 4, and this one distributing. You can distribute a -3, or you can leave it as a negative, and then you just distribute the 3, and then you'll have to subtract both terms. So you just have to be careful if you're changing to adding a negative, or if you're leaving it as subtracting a quantity. When you subtract a quantity, make sure you really do subtract the quantity. There's another one where once we got a common denominator, we did our FOILing, we combined our like terms, and we factored. This one was factorable. Then we canceled the common factors. There's what we have left. So this one, again, could be simplified once you did your subtraction. That's why I like the denominator to be factored and the numerator to be in standard form. So that is 6.3. 6.4 is division of fractions, and so you have a complex fraction, you have a fraction divided by another fraction. You can change it to multiplying by the reciprocal, but if there's addition or subtraction of multiple terms, for example, down here you have terms in your numerator and denominator, these kinds of complex fractions, the easiest way to deal with those is to do the LCD and clear those fractions. So if I multiply by the lowest common denominator of my denominators, 1, 1, x squared, 1, 1, x, and x squared, it's x squared. So I do it to each of my terms, and then I don't have any more fractions in the numerator or the denominator. So it's a standard fraction now. So it went from complex to a regular fraction. At that point, you factor and cancel any common factors. So the multiplying by the reciprocal method really only works if it's something of this format, where you have fraction over another fraction with where you don't have separate terms. So for more practice on the generic method, the LCD method, clear these fractions by multiplying by the LCD. Here's again m squared would be the lowest common denominator, or lowest common multiple. Then you factor and cancel common factors. For this factoring, since your a was not 1, you had to do the a times the c and then do your grouping. This time, it's this quantity x plus 3 that is the lowest common multiple, the LCD. Lowest common denominator is what you're multiplying by. You're not getting a common denominator. You're multiplying by it to clear the denominators with this method. So you distribute to both of those and to both of those. As you see here, the x plus 3 is next to each of the 4 terms. And it reduces just to nice integers. So it goes from complex fraction to a regular fraction that cannot be reduced. This time you have an x plus 3, a 1, and x minus 3 in the denominator. So your lowest common denominator would be x minus 3 times x plus 3. So I do that to each of my terms. That cancels any of the fractions in the numerator and any of the fractions in the denominator. And it reduces to this. I factor this. It's nice because the a is 1, so it's easier to factor. What multiplies to negative 12 adds to 1. What multiplies to positive 12 and adds to 7. And then I can cancel my common factors. So that's a couple examples. You can always pause and look at them and work them out for extra practice on factoring, but there's the method. I'm going to pause for just a moment.